Hey guys, welcome to this episode. My name is Danny, and today we're going to be talking about writable string, the second series, which where we're talking about how to use writable string as an implementer. Let's get started. So before we talk about how we create our child class inherited from this writable stream, I just finished up the last a statement, definition of the statement, or to talk about a writable end. So as you can see that the writable end statement is pretty similar as writable write, because it takes trunk, it takes a encoding mechanism, also the callback. So pretty much the same thing, but you know the difference is when you use the end statement and this method, and you just want to be finished with your writing. So just there's a little bit, a tiny little bit of question. When you give your callback, that means that when the end statement is finished, the task is finished, and then the node.js just call or invoke this callback. Then you can fulfill, or you can execute some of the specific options or specific tasks within this callback. So the question is callback and the finish events, because when you use end, so the end finish event will be emitted after the stream end method has been called. So this callback functions also be called, and the finish event will also be called at the same time. But which one will be fired first? I think you can have an experiment and to help you answer this question. And that's for this one. And you, as you are a implementer, you wanted to create your own subclass or child class and inherited from writable string. Just you can see how to implement your child class from streams, from four different streams. Today we're just talking about this one, a writable string which is inherited from writable string. So you have to give implementation implementation of a underscore write or and underscore write b statement, and also or underscore final underscore construct. Those internal implementation, you have to give the function definition or method definition for this definition for this implementation. So for writable, you have to give underscore read, and for duplex you have to give more, not only including the underscore read and also including underscore write. So that's because the duplicate string is writable string and readable string. And the same thing, you have to give some specific implementation for this inheritance. So there are three types of syntax to help you define your subclass. The first one is a pretty common one, just you require some writable and just class by using the keyword class. So just define your my writable and which extends writable string, and then you give your constructor. So just notice that you have to initialize your super constructor. Then you can give your own initialization for your subclass. And another type of writing your string or define your string, just use a simple mode. We call this type of syntax as a simple mode. Simple mode, because you don't need to use the keyword class to define all of your method and constructor, and also some of the implementation you have to give, and you just new writable and just initialize your instance. For example, in this case, it's my writable and the new writable, and you just here's the option. Not option, is the object. With the object, you have to give. So within the object, there's a lot of properties, and also some of the method you have to give. So that's the second one. Second one to define the subclass. The third one is before, we call it before a comma ES6. So you just use function instead of class. So I'm not gonna talk about this. The third one is the usage before ES6. So if you're interested in how to initiate your subclass from the writable class, just refer to this very detailed guide, and I just here I just give you some clues, because when you new a new stream, a new writable stream, you have to include the object, and then in this object definition, there are a lot of property like high watermark. You can define your own high watermark for your class instead of using default one. Default is 60K kilobytes, right, for writable, and also another one is decode string. As decode strings is a Boolean value. Normally we just leave it as it is. So decode string default is true, because when we look at the string, we talked about you can use your strings, you can use your buffer, you can use a unit array. So you have to have encoding method to encode your string and change it to buffer, because buffer is a low level object. So that means decode string, this parameter means if decode string equals true, that means you have to decode, encode in terms of your string. And the default encoding UDFA as default. So if you want to define your specific encoding method, just define this segment. And also you have object mode. Remember, there are two modes, object mode and non-object mode. So default is false. So default is the non-object mode. If you want to transmit, if you want to manipulate your data, but your data is not a node.js object, just the normal string or buffer or unit array, these three types. Close means that when you finish something, when you have, so your string will emit close event after it has been destroyed. Default is true. And these few guys is for implementation, because you have to implement, give your implementation for your subclass. For example, write, you define your own write function or a method to as the implementation for the internal underscore write method. That means that in this kind of syntax, defining a write function is equivalent to underscore dot write within the class definition, traditional class definition, the first syntax we talked about. So the same thing, a write b is equivalent to the underscore write b destroy, so on and so forth. Is that's how you initiate your instance, your own instance, writable string instance. So you have to fulfill or give implementation of this pretty important methods. And if we take a close look at our official guide, and we just give you a diagram on writable string lifecycle or lifespan, or just kind of like a state machine. So here we just new our writable string and invoke constructor, and then we can give our your own underscore construct, and it takes callback, a specific callback. This method, and if you give this is optional. If you give this method in your definition of your class, not your own child writable string, callback must be called. So callback must be, you have to ensure that your callback must be called within your this function. Otherwise, if you did not call this callback, then the further actions, for example, the underscore write will be delayed forever. So that means in this block, there's some preparation or initialization process you have to finish. And then with third block, there's general actions we can use. For example, we write something as we talk about as we talked about in the last episode. And we write something, we write many times, and we can use pipe to pipe other string and end pipe to, to tear down other pipes. So you can use it. Yeah. So this is a common actions you can use in the middle of the life cycle. And then if all of the action you're done with, and you just give the end statement. You have to use end statement to trigger, or just give this stream a signal. Everything we're done. We're done everything for writing. And then the end statement will trigger this or will invoke underscore final callback as a parameter if available. If you define this a score underscore final, CB should be called. That means that the same with the option underscore construct. This is a final clearance action you have to finish. So if available, and then finish event. This finish event or finish event end statement will trigger the finish event. Remember that? And the finish event will ensure all of the data has been flashed to the underlying resources. So that means if there is some data left in the internal buffer, so those data will be flashed successfully to the underlay. And then the next one will be underscore destroy. So finish event will trigger underscore destroy, but destroy the whole string, right? Destroy your instance. So underscore destroy if available. And then underscore destroy will close the event, will trigger close event to close the whole life cycle. That means if there is a healthy and a normal writable string, there are a lot of a lot of procedures you can encounter. So if there is an abnormal string with abnormal path, and for example, you just in the middle of the operation, you just give or destroy statement get executed, and this statement or this method does not guarantee that internal buffer data will be written to the underlay. That means it's an abnormal operation for this instance. So you just, for example, you manually destroy this string in the middle of the life. Then they also this destroy also trigger arrow event if there is an arrow, or it also trigger the close as a last step as a normal one. So other arrows, for example, other arrows from the underlay or from other specific block will occur and also trigger the arrow event to be fired. So you can see that there's a normal path, there's an abnormal path. So you can use this if you define your own subclass for writable string. You can define new underscore final underscore destroy. So you just manipulate the whole process for your writable. instance. So it's time for our snippet time. Hello guys, here's a snippet. So with this snippet, we can review what we talked about, lifecycle and writable, how to create your writable stream object. So let's go through this snippet. Here there are two parts, and the first part is how to create a writable stream class, and then as a consumer, how to use it as a second part. So as usual, we leverage a third party, a library, which is Chance, to automatically generate a random string with specific size, and here we create a class named writestream, extends inheriting from writable, and we have a normal constructor, and also invoke the super to initialize this constructor. And also we have a underscore constructor construct, and takes in a callback as a parameter. So this underscore construct will be invoked after this constructor. So that means within this underscore constructor function or method, internal method, we can use our own initialization or initialization code. For example, in this case, we have a file system. We open this some of the file. So as an initiation. So this is some of the work necessary jobs we need to start with, and we have our meat is underscore write, because underscore write will define how we write our writable stream or internal buffer data to out to underlining resource. Here we underline our underlining resource is a file system. So we right here we just call file system dot write. Now the stream dot write is a file system dot write, which means that right here this is some of the operation of for the underlining resources. Because have you remembered that when you are a consumer, you use write without underscore. You write your application data to your writable stream object or writable stream, and then underscore write will write you in writable stream or internal buffer data into the underlining, into the underlay. That's underscore write. And underscore destroy means that when you destroy some, as I talked about, there's a normal destroy, there's abnormal destroyment. So this part of this block of code will be invoked. for abnormal destroy and normal destroyment. And for the second part, we have we define a function f, blah blah blah, and we just initiate a writable stream as a writable stream object, and we define a specific bytes of random stream. Here, we just want to write a specific bytes of random stream into this cc.tst. That's our purpose. And with using this write function and a returning value will be used for checking the back pressure. And also I have a lot of log to indicate that the where it's running, and specifically show the whole life cycle. So we use a lot of console log to show the process, and I also add some event, for example, finish event, and the console log with finish event, and also give you a close event. So to see the whole, the whole life cycle, and then we just call this f function f with a 1600 kilobytes. That means the length of the string is 160 kilobytes. So let's run it. Okay. So here's the output from here. Here, those are our outputs. And false means we just print out the blood pressure signal right here. This is response, counts this one. This is a false means the response. False means that the internal buffer is go over the high watermark, which is 16 kilobytes, because every time we write with a length of 160 kilobytes, so this variable or this write response always set to false. 23 is our file descriptor number. So here we in underscore write method. Here we done, so they invoke twice because we write this one once, then we write again with end command. So writing 3 /n. So the internal writing will be invoked twice, and then 160,000 bytes written. That means we got right here. then all data sent in finish. So we trigger the finish because the end, we invoke the end method. So the finish event will be triggered, and the whole stream, this writable stream, will be destroyed. And then finally, the close event get fired. So that's the life cycle, or the order of the creating and then destroying the writable stream. So that's it. That's for this snippet. So you can practice with a lot of, you can create your own writable stream to practice with it. Hope it helps. And if you have any question and comments, just let me know. Write your comment down below. Have a nice day.